Video we are going to have a discussion how you can be able to answer question to do with locus, and we are having different types of locus here, whereby we are going to look at what does this locus that is given in this manner represent, what this represent, and also we are going to go ahead try to draw their representation on the agar diagram. And before we go into that, if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload a new tutorial on different areas of physics and further pure math, additional math, and also IGCSE videos, you'll be notified. In Proflan YouTube channel, I do matters physics and math for both Cambridge and Edexcel. Give this video a thumbs up. Let us now focus into this particular question. If you see a type of locus that is represented by the z plus 3i is equals to 3, then it means we can be able to rewrite this equation so that it can be able to be in standard form. Minus into bracket z minus into bracket, all locus are written in such a way that it's a minus here, so this is going to be 0 because this is a purely imaginary number, so meaning the real part here was 0, and then we can say this is minus 3i in that case is equals to 3, so that if you open the bracket it will be 0 here times this one, it's going to be minus, it's going to be positive 3. So this is a this locus represents a circle. This locus represents a circle of center, and this is the imaginary axis. Yeah, so which means this one, the center of this is going to be negative of course 0, it will be just 0 here. The center of this circle is going to be 0 minus 3. 0 minus 3, imaginary part minus 3 will be somewhere down here, right? And then the radius of this is going to be 3. This is going to be the radius, and then we're going to draw a circle of radius 3. So this circle of radius 3 will be a circle that is passing like that. Let me just move this 3 somewhere here so that we have minus 3 there, so that we can be able to draw the circle. The circle will run round like that. So this complex numbers that we are having here are representing a circle of center 0, negative 3 and radius 3. So this is the representation of the Argand diagram. But if you are having this, we can be able to say this can be written as z minus 2 negative 2 minus 3i is equals to 2. I'm writing that so that if you open bracket, you're going to get positive 2. If you open the bracket, you're going to get positive 3i. So the center of this circle is going to be negative 2, negative 3, and the radius of this circle is going to be 2. So on the Argand diagram, we are going to have negative 2 can be here, negative 3 can be somewhere here, negative 3, so that center of that circle will be down here. Then the radius is 2, so we shall have it moving up to this point, so our circle will be just like that. That is how our circle will be somehow looking like. The circle will be down there, and the radius of this is going to be 2, so you take note of that. How will this be? It will be z minus into bracket, this will be positive 3, so that negative times positive will be negative, then minus 4i, then is equals to 5. On Argand diagram, how can we represent that? And by the way, if you want to find the Cartesian form of this equation without the Argand diagram, you can as well use algebra, because this is z z can be written as x plus iy minus 3 plus 4i, like that, is equals to 5. And if you work it out, I'll put the like terms together here. It will be x minus 3 plus y minus 4, y plus 4 squared, or rather I modulus is equals to 5. Now if you square both sides, we are going to have x minus 3 squared plus y plus 4 squared is equals to 5 squared. Now you can see from this represents the equation of a circle, and from here you can see the center is going to be 3, negative 4, yeah, and the radius is going to be 5. So if you were to draw that on the Argand diagram, it will be 3, negative 4, to be 3 there. We can say negative 4 is here, so that center will be at that point, and the radius will be 5. So this negative 4, and if the radius is 5, this circle will be a big circle going through, yeah, going through down here like that, then it will pass this way, and yeah, something like that, a circle that passes like that. So actually you have to ensure that you are using pair of compass. We're using your pair of compass when you're doing that. This one represents perpendicular bisector locus. When you have modulus on both ends like that, it's a perpendicular bisector locus. So this is actually z minus into bracket negative 1 plus 2i. In standard form, I'm writing standard form because it has to be having a minus here. So is equals to z minus negative 6 minus 2i as well there, right? So to represent this on the Argand diagram, we have to draw the real and imaginary axis. One of the point is negative 1, 2, negative 1, negative 1, suppose negative 1 is here, 2 is somewhere here, that is z1, yeah. This one will be negative 6, negative 6, negative 2. So this is the imaginary and this is the real axis. So this will be negative 6 will be somewhere here, and negative 2 will be somewhere here. So this z2. This point, I think I need to draw somewhere you can be able to see. Need to remove this from here. Imaginary and the real axis. So the point here where z, the coordinate for the first point is negative 1, negative 1, 2. So we have negative 1 here, 2 will be somewhere here, that will be z1. The second point, it will be negative 6, negative 2. So if negative 6 is here, negative 2 is down here, so that will be z2. That's the second point. So which means that the line segment for those 2 points is this line segment that we're having at this point. So the locus defined by this is going to be the perpendicular bisector of the line segment z2 and z1. So the perpendicular bisector in this case is going to be a line that passes through the midpoint. And remember, the midpoint is going to be, the midpoint is going to be negative 1 plus negative 6 over 2, comma, 2 plus negative 2 over 2. So this ends up being negative 7 over 2, that is 3.5 negative, and 0. So that is going to be negative 3.5 and that point will be somewhere here, negative 3.50. That is the point where that perpendicular bisector locus is going to pass. So the locus defined by this is going to be a perpendicular line that passes through the midpoint, and that is going to be this line that goes like this. Yeah, so meeting that line segment at 90 degrees. So Z, set of values of Z that satisfy this condition are going to lie along this particular point. In terms of X and Y, so this is going to be modulus of X plus IY. This Z is X plus IY, and this will be plus 1 minus 2I is equals to X plus IY, because this is just a general complex number, and this will be plus 6 plus 2I. Yeah, so we are going to put the like terms together and then expand that by squaring both sides. So in this case, this is going to be X plus 1 plus Y minus 2I is equals to X plus 6 plus Y plus 2I. So if you work out this, you are going now to square both sides. So this is going to be X squared, no, it's going to be X plus 1 squared plus Y minus 2 squared is equals to X plus 6 squared plus Y plus 2 squared. If you square this, it becomes X squared plus 2X plus 1. If you square this, it becomes Y squared minus 4X plus 4. If you square this, it becomes X squared plus 12X plus 36. If you square this, it becomes plus Y squared plus 4Y plus 4. At this point of time, you can see X squared and X squared will cancel out, Y squared and Y squared will cancel out. I want to remain with n term, or this part here. This part here is Y. Yeah, this part here is Y. This one. I want to remain with Y only on this side. But if I bring this Y on this other side, we are going to have negative 8Y. And then I'll have to take 2X on the other side. So that will be 10X, because it will be 12X minus 2X will be 10X. And then I'll have, this is 1 plus 4, it will be 5. I take it on the other side. I'll say plus 36. This is actually 36, and this 4, it becomes 40 minus 5. Yeah. We are done with the 4Y. Yeah. So it will be minus 8Y is equals to 10X plus 35. Divide by negative 8, divide by negative 8, divide by negative 8. This will cancel out. Y is equals to negative 5 over 2X minus 35 over 8. Now, with that particular equation, so the equation of this locus that's represented by that question is Y is equals to negative 5 over 2X minus 35 over 8. You can be able to use this method in order to find the locus in Cartesian form, or you can be able to use the midpoint, or first you find the gradient of Z1 and Z2, then you use M1 times M2 to get the gradient of this, and then use that gradient you'll get with the point which is the midpoint in order to find this particular equation. Or you can be able to use algebra, perform this question that way. So if 3 is that, we are going to draw a line which is parallel to the x-axis like that. Then our locus is an angle of 45 degrees measured in the clockwise direction. So the locus is going to lie anywhere along this line. So this, our locus can be anywhere along this line, excluding this point that we are having here. So that's the angle we have 1/4 pi, which is actually 45 degrees. Yeah. So in the event you are given arg of a complex number z minus 3 minus 2I is equals to 3/4 pi. So that means in this case our point is going to be 3, -2. So when we are going to draw our Argand diagram, our imaginary axis will be this, and the real axis is that. Then -2 can be down here. So we are going to draw that point there. Yeah. Once you have drawn that point here, of course we are assuming that this is our -2 here, and we have our 3 here. So which means we are going to draw a line which is parallel to the x-axis. So this line is going to be parallel to the x-axis like that. Then we have the angle. The angle is 3/4 pi. Which angle is that? Angle of 135 degrees. So if in degrees that's 135. So if I want to draw it accurately, I'll just come and put my protractor at this given point, 135, in anti-clockwise direction because it's a positive angle. So 135 will be here, this point here, so that I can be able to join. So the locus is going to lie anywhere along this, and the angle is measured in anti-clockwise direction. That is 3/4 pi radians. Yeah, so that is how these half lines are drawn. And if you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial, you'll be notified. See you in the next video.